Welcome to Trigonometry. So the first couple of sections that we have is going to focus on a lot of recalling of what we learned in geometry. So let's kind of get through a lot of the definitions and the terminology, and then we can get into the fun stuff of actually doing math, because that's what we're here for, right? All right, so before we get into all that, we got to talk about some definitions and some terms. So first of all, in geometry, sometimes we want to talk about what just a point is. Now understand that a point like this, point A, all it is a location. There's no height, there's no length, width, depth, or anything like that. It's just a location. Now, if we string together an infinite number of these guys, then we can form a line. Now, sometimes lines are given by a letter that's written in script next to it, so we could call this one line L. It could be named by any 2 points that happen to be on the line, like this. And so this diagram would be called line BC, and we would use this notation above the B and the C like that to denote that it is a line, as compared to a line segment. So a line segment would be something kind of like this, where it's kind of like a line, except you have endpoints on both ends, and it doesn't continue on in both directions like a line does. So let's call this, I don't know, maybe we shouldn't use C. Let's use D and E. And so we would call this one line segment DE. So having that bar across the D and the E denotes that it is a line segment, compared to what you have right here, where you have the line symbol above the B and the C. Now understand that this is not the same as DE. Okay, so this is the actual line segment. But this is the measure of the line segment DE. In other words, it's the distance from D to E. So I want to make sure you understand how to properly write the notation for a line segment versus the measure versus just writing a line. And now if we go down a little bit more, we could have something like this, where it's kind of a mix between a line and a segment, and this is called a ray. So a ray is given by a vertex, let's call this X, and you name it, the other part of it, by a point that it goes through. Let's call this one Y. So this would be ray XY. We always name it with the vertex first, and then the point that it goes through is going to be the second piece that we have. So this is what we would call ray XY. And if we were to take this ray and we were to form a different ray off of this, and let's have it going through the point Z, so now we have ray XZ. Having two rays with a common endpoint creates an angle. Okay, so there are a lot of different ways of naming this. A lot of times you'll see, say, a number on the inside like this. So we can call the actual construction of the angle, we can call it angle 1. We could call this angle X. But you've got to be careful. You can only call it angle X if that is the only angle that has X as its vertex. Otherwise, you would have to use the 3-point naming system, which would be, in this case, angle Y, X, Z. And the reason it would be angle Y, X, Z is because as you trace along and you form the angle, it would be going through Y, hitting X, and coming down through Z. So you can write it in that order, or you could say angle Z, X, Y. Again, note here that the vertex of the angle is going to be the middle of the 3 points that we have that kind of give us the shape for the angle. All right, now when we talk about angles, a lot of times we want to talk about like the two sides of it. So you have what's called the initial side and the terminal side. So the initial side is going to be something like this. It's just going to be part of that angle. And we kind of consider this to be fixed. And we would talk about how we would create an angle by rotating a ray around it like this. So you get one guy that's fixed, and you just kind of rotate around. So as I rotate around, I can form an angle by having the ray that does this. Oh, I don't know why I did that. There we go. So in the example that I did right here, we would call this the initial side. And we're forming this angle like that. And we would call this the terminal side. Okay. Now, for a lot of the angles that we talk about in this class, we're going to be talking about them being in what's called standard position. All right, so standard position is you are taking the regular XY plane like this, and you are going to fix one side of the angle along the x-axis. Okay, so I'm using this highlighter, making it look a little bit larger than it really is. So that guy's going to be fixed. We have it along the positive x-axis, and then you are creating the angle from here, and you're rotating it over like that. So when we do the angle rotations, positive angles are going to be going in a counterclockwise fashion. If you go in a clockwise fashion, that is what we call a negative angle. All right, so yeah, so this would be an angle that's in standard position. Again, you have your terminal or your initial side over here that's fixed, and then you have your terminal side where it ends over there, and that's the one that's going to vary. So when we do a lot of these diagrams, we start by drawing along the positive x-axis, and then we kind of rotate, positively or negatively from there. So, for example, this guy right here might have an angle measure of, let's say, 135 degrees. But we could have an angle that does, say, something like this. And so if we were to measure this one, if we go down like this, we might say that this is, say, negative 65 degrees. So it's all about how you rotate, and that's going to determine whether you have a positive angle like this one or a negative angle like that.